Hello, this is Phong Tran. I'm a grad student from HPMI, and today I would have a very brief talk about the X-ray system that we have here at our material research building. And with the naked eye of human, we can only observe the thing at the visible light that range from 400 nanometer to 700 nanometer. And in order to characterize the material at the level of nanoscale, we need to use the equipment that can have that capability to do that. And X-ray is a very powerful equipment that can help us to characterize the material at small scale. So the range, the wavelength of the X-ray diffraction is from 0.1 to 10 nanometer, and when the incident X-ray beam that generated from X-ray chamber hit onto the material, it will reflect it and it will follow the Bragg rule. And the spacing, the D spacing is the space between the two atomic planes. It can be used to identify the material. By using the detector, we can record the maximum intensity of the X-ray that follow the Bragg rule on the film, and we can learn a lot from that data. So the system that we have here is the NANOSTAR from Bruker. That is the X-ray diffraction and elemental analysis system. This system is very powerful. It can do small angle X-ray scattering and wide angle X-ray scattering. For small angle scattering, it will learn the property of the material with the D spacing from 10 to 100 nanometer at the particle and the electron density charge of the particle. And with wide angle X-ray scattering, the 2 theta angle is from 4 to 60 degree. And the application of this system, it can tell us the distribution of the size and shape of the material. It can tell the orientation of the material, of the crystal inside the material, and it can tell the mean distance between the particle. So today we will run the X-ray measurement on the thin film materials. And at first you have to locate the location of the sample inside the chamber. And we can use the nanograph function, and by that the software can tell us where the exact location of the sample in the chamber. And after that we can load the film. The film is for wide angle X-ray scattering, and the detector of the system is for small angle X-ray scattering. And we can run it for the time that normally we run for 10 minutes, but it depends on the intensity, the scattering intensity of your materials. It can be, if it's strong, you can only run it for a lesser amount of time. And if it's the width intensity, you have to run it for a longer time. And once you get the data from the film, you can scan the film and get the data using the scanner. And by that, you will have two results at the same time: the small angle X-ray scattering and the wide angle X-ray scattering.